Today, we're going to pull back the curtain on programming. We're going to reveal the simple but really powerful ideas that basically run our entire digital world.
Have you ever just looked at an app on your phone and thought, how does this actually work? How do a bunch of lines of text on some programmer's screen turn into a complex game or your social media feed? It kind of seems like magic, right?
But here's the thing, it's not magic. Not at all. In fact, every single piece of software you've ever used is built from just 3 fundamental ideas. That's it. If you can get your head around these 3, you'll understand the foundation of all code. Seriously.
Okay, so first up, let's talk about the blueprints. The best way to think about these is like the core rules of logic. It's how every program thinks and acts.
The first, and honestly the most basic blueprint, is something called sequence. And it's exactly what it sounds like. A program just follows instructions one after another in a very specific order. It's just like following a recipe, right? You can't bake the cake before you mix the ingredients. Order is absolutely everything.
And here's a perfect, simple example of sequence in action. Look, step 1, the program asks you for your age. Step 2, it just waits for you to type something. And then step 3, it prints out the result. See? It's simple, it's logical, and it always happens in that exact order.
But, things aren't always a straight line, are they? Sometimes you got to make choices. And that brings us to our second blueprint, selection. This is how a program actually makes decisions. Just picture a fork in the road. The program gets there, and it has to choose which path to take based on some condition.
So in this case, the program checks a condition like, is the age greater than or equal to 18? If that's true, it goes down one path and prints, you are an adult. But if it's false, it takes the other path and prints, you are a minor. This simple if this, then that choice, that's the foundation for pretty much every decision a computer ever makes.
All right, our final blueprint is iteration, but most people just call it looping. And honestly, this is the computer's real superpower, doing the same thing over and over and over again without ever getting bored. Imagine you have a giant stack of dishes. You just repeat the same action, wash, rinse, dry, until they're all gone. That's a loop. So this loop right here, for example, just tells the program to print hello exactly 5 times. No big deal, right? But what if you told it to do something 1,000,000 times? Or 1,000,000,000? It's that ability to repeat a task flawlessly again and again that makes programs just so incredibly powerful. So, okay, we've got our blueprints for how code thinks: sequence, selection, iteration. But those instructions, they need something to work with. They need materials. And in the world of programming, our materials are data. Let's take a look at how that's handled.
Honestly, the absolute best way to understand data is to just think of different kinds of containers. I mean, you wouldn't store milk in a paper bag, right? That would be a disaster. The same exact logic applies in code. You've got to have the right container for the right kind of information. So here's a quick look at some of the most common data types, our containers. You've got int for whole numbers, string for text, bool for simple, true or false, and using the correct one isn't just about being neat and organized, it's actually crucial for making sure the program runs efficiently and, doesn't crash.
Let's zoom in on the integer, or int for short. Just think of this as your small, reliable box. It's perfect for holding whole numbers. Things like your age, the number of items in your shopping cart, maybe a year, all of those fit perfectly inside an int.
Then we've got the string. This is more like a long container, maybe like a tray or a long box, and it's designed to hold a whole sequence of characters. It could be just a single name, like Rashid, or it could be an entire paragraph of text. The rule is simple. If it's text, it goes in a string.
And finally, we have the Boolean, or bool. This one is the simplest container of them all. Seriously, it's just a light switch. It can only be on or off, true or false. That's it. And these little switches are absolutely essential for making all those decisions we talked about with the selection blueprint.
And just like containers in the real world, these data types come in different sizes. And that's all about efficiency. You'd use a smaller box, a short, for a small number. But if you needed to store something massive, like a country's population, you'd need a much larger one, a long, just to make sure the number actually fits inside.
Okay, so we've got our blueprints for logic, and we've got our containers for data. Now for the fun part. Let's put it all together and see how these simple little pieces can combine to create a real, actual working program.
First things first, a program needs a way to communicate. So it uses an output command to talk to you, to display messages and results right on the screen. And then it uses an input command to listen. It just sits there, waits for you to give it some data. It's really just a two-way conversation. Okay, now let's actually trace the flow here, step by step. Step 1. The program prepares its containers. It creates an empty string for a name and an empty integer for an age. Step 2, it talks to the user, asking for that info, and then listens for the input. Then, step 3, it uses our selection blueprint to make a decision based on the age you entered. And finally, step 4, it gives you a totally unique response. You see? All our building blocks, sequence, selection, data, all working together in perfect harmony.
And that's really the key takeaway here. Whether we're talking about your banking app, your favorite video game, or the entire operating system on your computer, at the end of the day, it's all just an incredibly clever and massive combination of these super simple building blocks we've just talked about.
So, we've laid out the blueprints and we've shown you the materials. You now actually understand the fundamental principles that power our entire digital world. So the only question left is, what are you going to build with them?